Hey, hello, and welcome to the show. It's me, JP. It is time for John Park's workshop, and it's all about not Bluetooth bridges. Thank you for the catch. Cochran over in YouTube noticed that I had a spelling error going. Fixed it real quick, it is now Bluetooth bridges. That's going to be the topic for the project today. Here we are in the workshop. What's happening? Let's talk about what's going on in the show today. I'm going to have a coupon code for you so you can save some money in the store. I've got a recap of the product pick of the week this week. I have a CircuitPython Parsec for you. I have a little bit of a related gear report tooltip kind of thing. What else? I've got a project to take a look at, this Bluetooth bridge, keyboard bridge thing. And who knows what other fun we'll have along the way. So let's kick it off with this is the coupon code today for 10% off in the store. Head on over to Adafruit.com. Throw some stuff in your cart that is physical stuff that you can have us ship to you. So it won't work on gift certificate subscriptions or software, but it will work on things. And then type in the coupon code slot blue teeth. That's easy to say. Blue teeth. Blue teeth will get you 10% off in the store today. I've actually never determined if case capital matters for these, but I did it all caps today, so maybe try it that way. And you will get 10% off on some cool stuff. If you take a look what kind of cool stuff we've got going on right now, let me slide that over there. Bring up my browser window. You can head over to Adafruit.com. That's the store right there, the first page. Take a look at some of these new products here. If you click on View All New Products, I'm so excited that we have these now in stock. These are these slim right-angle USB-C to USB-C cables. I tracked some of these down when I was working on the LED dance shoes project, and I needed a minimal USB cable to navigate the confined space that I was working with. These are perfect. In fact, I heard from Lamore that Phil has found a use for these. It's just snaking it under a window, windowsill, window pane, whatever you call it. These are real thin, so easy to get where you need. And now we've got a few sizes of these as well, and a couple of orientations. It's going to be the 150, the 100, and the 75 millimeter lengths. And then there are both connectors facing the same way or the opposite way, which is can be really useful depending on the setup you've got. Oh, and 40 millimeter and 23 millimeter. I've seen some of those advertised as when you just want to like stick a battery on the back of your phone and do a direct USB-C to USB-C connection. Those will work well for that if you just want to glue it on there or something, if you don't have all that MagSafe going on. That is so stubby. I want one. I love it. But you can see we've got a whole bunch of cool new stuff that is in, and if you want to save 10%, then use that coupon code to Teeth. That's going to be good until midnight East Coast time, United States tonight. So don't sleep on that. Who am I talking to? It's you. Thanks for stopping by. Over in our chats, we've got the YouTube chat, and over there, hello to Robert Cochran and Beata Graf Avdelhagen and Dave Odessa. Thank you for popping in over there. We also have our Discord chat, so if you're wondering where to chat, go to adafruit.it/Discord. Go to the live broadcast chat channel on our server there. Hey, John Nodge and Paul Cutler. Thanks for popping by. Window sash was the word I was looking for. Thank you. If you want to lower your Windows sash over some very minimal USB-C connection, then that one of those cables might be the right one for you. I don't think I have any right here. I think those are in use in those shoes. I just bought like a little, I think a 3-pack of them. So next up, you know, I've the show on Tuesday. That's the logo or the thumbnail from this week, which is the product pick show. I pick something new or from the archives of Adafruit products, give you a big discount on it and a demo. This week was fun. I got to build a little Euro with a split power supply. So that's not me. That's probably a Belgian martial artist. Let's take a little look at the recap. The TPS65131 split boost power supply. It can give you -6 to 15 volts on one side and +6 to 15 volts on the other side, DC. Super useful for portable USB battery powered Eurorack cases. The USB-C phone battery here. There you can see I've got a little USB-C breakout, and then that is running ground, and the V-bus, so the 5 volt, are what's powering the split boost supply. And then I'm running out the -12, +12, and the 5. And then this little yellow wire here is the enable. Turn this on, watch the lights down here. The TPS65131 split boost power supply. All right, let's see. Next up, let's launch into, I'm going to actually prep my here in advance, into a CircuitPython Parsec. CircuitPython Parsec. Okay, I think that's pretty good, and I'm just gonna switch to this one. That's the Arduino. We're not doing Arduino Parsec. Oh no, my software is getting slow to respond. CPUs are spiking. Hopefully that's still streaming reasonably well. Let me take a look at the YouTube health stats. Hey, stream is healthy, it claims. Okay. I just want to connect up to the REPL here, and we should be good. So for the CircuitPython Parsec today, I wanted to talk about how you can use the Wii controller or Wii Classic controller as an I2C input to control some graphics in your program. So last time we took a look at just registering button presses from a classic controller, and that can be something like these modernized Wii Classic controllers or those Wii Classic controllers from back in the day. Anything with that little I2C Nintendo proprietary controller on it, and then I have that plugged into a Feather using our little adapter board. And in this case, over SPI, the Feather is controlling one of these lovely sharp memory displays. We have a little sharp memory display and breakout from Adafruit. These are great. They're black and white. They're actually what's used in the Playdate controller, or the Playdate game console. We'll talk about that later. And what I've got happening here is just a little simple sort of beginnings of a demo where the D-pad on my controller is moving the X and Y of that little dot, little vector IO dot. I can reset the position with B, and I can also place, I can increase the scale or the size of that little circle by pressing this button. Oh, we've gone off the screen. I didn't put any boundaries in just to keep the code super simple for now. So how this works, if you take a look in CircuitPython here in my editor, I've got some library imports, so time, board for pin definitions, display I/O, frame buffer I/O, actually I'm not sure if I'm using that one, I think I am, vector I/O for drawing the circle, and then I'm using the Adafruit Wii Classic library so that I can talk to different Wii controllers. And then also using a Adafruit display shapes rectangle just to create the white background there. And I'm importing the sharp display, so it's specific to using this memory display. We clear the displays by using display I/O release. And then I'm setting up that memory SPI bus of the feather with these options here. Frame buffer is sharp display, sharp memory frame buffer, SPI, board 4, might be the interrupt, I can't remember. 400 by is the width and the height in pixels. And then we create the display object from that frame buffer. Then I'm also creating an I2C object from board stemma I2C, and then setting up that Wii controller on I2C. Do a couple of other display I/O things that I won't and I'm creating a move step. This is how far in frame of move, and I have it going just a little bit more than width of the circle. So it's smooth, and you can adjust that to go faster but choppier or smoother and slower just by adjusting that step per cycle. We're setting up the black and white palette to use for the background and for the circle. And then I'm creating a circle dot as a vector I/O circle with settings, and appending that to the display. Then in the main loop of the program, we'll skip down here, we are checking for the state. Moved is going to flip to true anytime the D-pad is touched. When one of those buttons is touched, and this is using that I2C read, we say control pad D, the control pad D-pad up or down or left or right. If one of those states is true from that I2C message coming from the controller, then we're going to adjust that by the move step. So if we go up, we're going to take the Y position and zeros at the top. Left, add, subtracting, and so on. Moving those directly, but instead just change the variable and then saying, okay, we've moved, is so that we can any of those, particularly if we want to go diagonally, we're going to check both and Y, and then we update that dot. So if something has moved, the dot x equals dot x variable and dot y variable, and that's what keeps it from doing little steppies, but instead jumping to the position as directly as possible. If the A button is pressed, then we're going to adjust the radius, and if the audio dropping is getting, sorry to hear. If the button is released, then we're going to radius. And finally, if the B button is pressed, then we're just going to jump to that home there. Oh yeah, someone said it's breaking up really bad. I don't see, let me see here. Is it? Check. Could be. Let me just check sorry about that. Let me just check my microphone connection here. I'm going to pause the audio for a second. Hold on. All right, well, hopefully that's a little better. I just removed the microphone from the mic pack and reinserted it. So I'll finish this. If I have to re-record this later, I will. Let me know if that continues to be a problem. And so that is how you are able to use a I2C Wii controller to adjust the position and scale of a graphics object inside of CircuitPython on the Sharp memory display. And that is your CircuitPython Parsec. All right, let's take a moment to see how the audio is doing. Some nice over in the chat showed yes, for sure, right? The Game & Watches from Nintendo have very much that same 1-bit feel, even those were an LCD. Yeah, John Nudge said, didn't want to interrupt, but it was making it difficult to follow the explanation. You know what? Let me know if the audio seems to be cleared up with the fixing of the mic pack, or reinserting the mic into the mic pack. What I'm worried about is that it could just be a processing thing. So I was saying my computer was acting a little slow. I did a restart on it. Hopefully it's still healthy. If the audio seems to be stabilized, then maybe I'll redo that CircuitPython Parsec in a little bit. So why don't we'll go on to something else now, but if it seems like, if you can let me know if it seems like the audio is in the clear, then we'll redo that one. I'm just checking the other chats. Yeah, Badagraph up to Hagen saw the same thing. The question from Robert Cochran over in the YouTube chat is, are you using an old version of Python? The bottom pane of your Z screen seems to reference Python 3.9. Yeah, I have not. I think this computer here has like a weird Python installation where I had Anaconda on at one point, and it's all goofy, so if it's working, I'm leaving it alone. So yeah, I don't know what's Python up to. That Python it's referring to, by the way, is the Python on the computer, not the Python on CircuitPython on the machine. All right, yeah. So let's leave that for a moment, and we'll see how we do. I will. Let's use this opportunity to talk about this little guy. So here's a little gear report thing. I cannot remember if I've shown this lovely little gizmo before. You may have heard of these. This is the Playdate from Panic. And it is a little handheld game console. It happens to have a couple of different options for covers, and I couldn't resist the pizza box cover. Sorry, it's kind of blown out on that screen. I'll show it on the down shooter here so you can see this in all its glory. Let me drop down to here. So you can see delicious hot square pizza, classic pizza box illustration. That is magnets for closure, and magnets and little pegs for connection on the back. One of the interesting things that they did on this is, I think at least 2 of these, maybe all of them, of these little standoff threaded split screw things, whatever they're called. These allow you to charge, so ground and 5-volt on 2 of these will charge the device, and that was for future proofing. They wanted to have a stand you could plug it into, which they gave up on a little while ago because it was, I guess, proving difficult to manufacture. But this gizmo was designed by Teenage Engineering, who are a design firm in Sweden who've done a bunch of synthesizer stuff and other really cool work. And this is the same Sharp memory display. So if I double click this and go home, you can see same. You get this under the same light, same size, 400 by 200. I think the bare display is identical, and it's a monochrome display, 1-bit. So all of the graphics that you'll see on this are done with dithering and patterns and halftones and stuff like that. So if I go here, you can see some examples there of like pseudo grayscale done with little horizontal lines, patterns, and so on. So these are really neat. They've got a crank on the side, which can be used for some stuff in the UI of the OS, and of course some stuff in games. But it's also just a really nice little D-pad AB, so very Game Boy style. game. You can sideload games on there, so you can buy stuff or get free stuff on itch.io and other places. You can make your own. You can subscribe. You can buy games from Playdate. They also have this season of, I think it was 24 games initially. Might have come with it, and then the season 2 just came out, where they every week or so unlock another game for you. So you buy the whole season, and you can wait for them to come along. So you'll see I've got some games on here I haven't opened yet. Where are they? Other direction. Go up to the top. Oh, maybe I've opened them all. Yeah. So there's like a little wrapping paper. I thought we saw one. Yeah. So there's the game I haven't opened yet. You can crank the crank to start. Oh no, you can't. I guess you press A to start unwrapping that. I'm not going to do it right now. So really neat little system, and it does come with a couple of different ways to do development on it. There's a code-free development environment called Pulp, if I remember correctly, and then you can also code in Lua in the game, more fully featured game development environment, as well as C. And let me go to a web page for a second. Oh, hello, other me. And take a look here at, so I think they're just at play.date. Panic is a really cool company. They've done Mac software forever. They made, what was it called? There was a FTP software. Let me go to Panic software. Panic Inc. Transmit. Yeah, Transmit is a really popular FTP software. So they were in the software development game for a long time. Then they published some games, including Firewatch. And then this hardware came out a couple of years ago. They were very hard to get for a while for various reasons. They are now pretty much caught up, and I think you can just buy them. You don't have to wait around. I think I waited a year or something for mine to come. But if you take a look on the development, so there's a Playdate SDK. There's also this Pulp GUI-based game dev thing. And I would love to dive into both of these sometime. So you can put kind of anything you want on there. I think at one point Scott was talking about trying to see if he could get CircuitPython on it. Maybe one day we'll do that. It's a M7 chip inside of there, so beefy and fast. So that's the Playdate. And I just wanted to show that off because it was one of the inspirations for doing some development with this little sharp memory display here. These, by the way, have no backlight. They are awesome outside or with a nice light source. Things like little worm lights help, or book lights, or little visor things if you're trying to play in the dark, because otherwise it's reflective only, so it's going to be pitch black. So there you go. That's the whoop, whoop. That's the Playdate. Also just shows up as a clock when you're not doing anything on it. And low power, so I think this can just act as a clock for a long, long time without you worrying about batteries dying on you. It has a little speaker on there, I think a little mic built in, and then there's headphone out. I think that's the mic, and there's USB-C. That's the Playdate. This is not paid for, and I'm in no way affiliated with Panic or the Playdate. I just think it's neat. All right, so let me know if you think that was audio was working well enough. I will actually redo that Circuit Playground CircuitPython Parsec so that we can get a nice clean version of it and you can hear what I was talking about. It looks like from the chats, some people say it settled down. David Essa says, thanks. It seems to have stabilized. All right, well, maybe we risk it. Let's get set back up for that, shall we? Get this back under the center here. Yeah, that'll work. We're good to go. Robert Cochran asked, do the games on the Playdate have to be paid for? Yeah, most of them are. There are free ones out there as well. you can make your own game, put it on there, all possibilities. It doesn't have to be purchased, and it does not have to be purchased through Playdate. You can buy stuff through their kind of catalog. You can buy stuff on itch.io, seems to be a popular place, but you can sideload stuff. They have no qualms about you just putting games onto it, so they're not trying to make it difficult, and they're not trying to gatekeep making a cut or anything like that, as far as I can tell. So if anyone else has experience with that, let me know. But yeah, most of these ones I have on here were either from that first season or pretty inexpensive ones that I bought, and I think I have a few on there that were free as well. All right, so let's try this again.
CircuitPython Parsec.
All right, for the CircuitPython Parsec today, I wanted to talk about how you can use a Wii controller on a CircuitPython microcontroller with a display in order to have a, let me say this again. For the CircuitPython Parsec today, I want to show you how you can use the Wii controller as an input for graphics on a microcontroller with a display. So in this case, I've got a Feather RP2040, and I'm using this really cool Sharp memory display. I've got an official Nintendo Classic controller with our little breakout, because these are I2C. And you can use the very classic Wii controller or any of the other gizmos that have that proprietary Nintendo Wii Chuck adapter that happens to be I2C. And the way that this works is I've got it set up right now so that I'm moving this little vector IO dot around the screen using the D-pad on the controller. I can press buttons to recenter that if it's disappeared off the screen. And I can also press the A button to double the size of this sphere here. I'm not doubling the speed, so it kind of moves around a little more, looks a little more loafy now. So the way this works in CircuitPython, you can see here, I'm importing some libraries, the time board for some pin definitions, display I/O, frame buffer I/O, vector I/O for that fast drawing circle on there. The Adafruit Wii Classic library allows me to use this and other Nintendo Wii Chuck adapted controllers, as well as the display shapes rectangle to draw the white background, and the Sharp display library for this Sharp display. We release the displays to free up any resources, and then I'm using the SPI bus to connect to this display, and then setting up a frame buffer that's 400 by 240 for that display, and creating the display object. Then I'm initializing I2C as the board stemma I2C, where I have that adapter for the controller plugged in, and creating the control pad object. And then we throw up the background, create some colors for palettes, set the size of the dot as well as how fast it moves by step size, which right now I have just a little bigger than the diameter of this sphere or this circle, so that it moves pretty fast but is still smooth looking. And I'm also setting that initially to the center of the display just by dividing the width and the height. Then we create the palettes and the dot object with those settings. And then in the main loop here, you can see I have this variable for state called moved, and that just checks to see, has any of the D-pad direction buttons been touched? If so, then we can update the X and the Y position of the dot. The reason that we don't just directly move those is I want to avoid stair-stepping when we go diagonally. So we look to see what's changed, and then when we know which, it could be up and left, have changed, then we apply those to the actual XY coordinates of the dot. So we check that for up, down, left, and right, and you can see I'm moving that based on that move step size that I set up earlier. So then if moved state has been updated to true, then I set the dot X position to that variable and the dot Y position to that variable. And then for the circle to return to the center, I've got this, the B button. So when I press B, we're going to set that back to the display width and height that it was originally at, sort of center of the screen. When I press A, while that's being held, double the size, and then when I release it, we go back to the original size. And we can still move while we're while we're big like that, as I showed before. This is if we're trying to move and center ourselves. It's just fighting back and forth between those. And so that is how you can use the Wii controller as an input for graphical update inside of your CircuitPython code. And that is your CircuitPython Parsec.
The CircuitPython Parsec.
All right, with any luck, that audio worked better, so I could compare and contrast later, I suppose. One thing I used to do sometimes when I was having problems with just the broadcast, because I don't know if you know this, when this goes out, it actually gets turned into a recorded video by YouTube. So I usually download that to then cut out sections that I use later. I do have the ability to record locally, so the highest resolution version uncompressed can be recorded to disk, like a ProRes one, so that it doesn't eat up as much resource. It eats up a lot of disk space. That will save locally, and then I'll use that. So if I have problems with broadcasts consistently, I might start recording locally again. Just some inside baseball and how all that works. Starman says, good job. Okay, good to go. Thank you. Audio seems to have worked on that one, so we got a cleaner take. Thanks for your patience with that. And now's a good time, I think, to move over to this Bluetooth bridges thing. So let me jump over here for a second and talk about a couple little things with this Bluetooth. So one of the biggest confusions for me with Bluetooth, I think, has been Bluetooth Classic versus BLE. How to use them, how to know which is which, what can use them, why. So I've got a couple of keyboards here, and I'm just going to bring up my Discord so I can see the conversation. There's actually, I don't know if there's any way really to tell on these two keyboards if they're using for their wireless Bluetooth or Bluetooth LE, or I should say Bluetooth Classic or Bluetooth LE. This 8-bit DOE controller has a switch for off, which means we're just going to plug in over a cable. It has the 2.4 gigahertz, which there's a dongle here that I don't have stored under here. It's inside the house connected to a computer. So you can go with that direct 2.4, and that's a really nice way to do it, because then there's just a constant permanent pairing between this device and that dongle. In some cases, you might want to create that yourself, and that's what this little Bluetooth bridge project is about, is particularly for keyboards that don't have this, that can't just switch over to 2.4 gigahertz. We want to be able to receive Bluetooth or Bluetooth LE on a Pico W, or Pico 2W. This happens to be the Pimeroni version of it. This is a Raspberry Pi version of it. And then using USB HID, send out keyboard HID control to the thing we're plugged into. So this can be good for a computer that doesn't have Bluetooth, maybe a microcontroller. I'm going to start working on getting this to work on the Fruit Jam so that I can use wireless keyboards with the Fruit Jam. And this will just act as a little bridge between some kind of Bluetooth wireless coming in and then HID going out. So this would look like this sort of, oh, that's the wrong one. This would look like this sort of thing. So this is a USB cable, C on one end, A on the other. That goes into the host computer, Fruit Jam, etc. This one here happens to be BLE. Although it says BT on the little switch here, when I switch to that, you can see it's blinking, trying to pair, trying to connect to something right now. This one is a Keychron, and if I switch this to Bluetooth, they both say BT. This one is Bluetooth Classic. I can put this into pairing mode. It's a little Vulcan nerve grip here, so that's got the first channel of Bluetooth Classic attempting to connect. We can use 1, 2, and 3, and that's useful for cases where you might connect this to multiple devices. You can switch between them. So in initially doing this project, and when I showed this on Show and Tell a couple weeks ago, I had this one connected. I thought I was connecting to Bluetooth, and I didn't pay enough attention. It turns out this one wouldn't connect to my little Pico because I was only actually allowing BLE connections, and that's what this one is. So I've gotten all that straightened out. I have Arduino code running that will work on the Pico W, the Pico 2W, the Plus version, all of those, and allow these to sort of act as a unified bridge. When I start this up, it will look for a Bluetooth keyboard first for a few seconds, try to connect, and if it can't, it will sort of close down that bit of code and purge the Bluetooth stuff, and then bring in the BLE stuff and try to do that connection. And it'll just ping back and forth between those. So I thought it would be cool to show a live demo of that in action. What I'll do is, let's see, I think it'll be easiest to do with that display there. Or, you know what, here's how I'll do it. I'm going to connect this little dongle, my little Pico, up to the desktop computer and just show a little, we'll show the Arduino, and I'll be back there on that one. So let's move this here. And I'm going to plug in, yeah, I guess let's do this Pico Plus 2W first because it's got a USB-C connection. So I've plugged in, and you can see in my, let me set up the serial monitor here. Port, great. I'll reset this. So that right there, you can see, just showed up in the serial display here. It says starting Bluetooth stack initialization, Bluetooth classic only mode. It initializes the Bluetooth classic stack, which uses this HCI for the events. Looks for the keyboard, it scans, it's not finding it, so then it says I'm closing that down and I'm falling back to BLE. It initializes the BLE stack, goes to try to find a keyboard there. I think it says it's gonna, okay, it timed out. I thought it was trying to connect to something, and I'm like, oh gosh, who knows what's connected in here. So let's, I'll try to keep an eye on that, and I'm gonna come over here and turn on pairing mode for the Bluetooth keyboard. Okay, so that's in pairing mode. I'm just going to double check that my cursor is somewhere that we'll see it if I type. I'm just going to put it right here. So it just said the classic connection is complete. It found it. It found the name. This is the Keychron K8. Found the MAC address of it. Created the L2 cap control channel, HID control channel, interrupt channel. All of the Bluetooth protocol handshaking has been done, and now I can type in this window from the BT Classic keyboard. Yay! So that, hopefully you could see that in the serial monitor there. I know it's a little small. So that's connected to Bluetooth Classic. What I'm going to do now is put the BLE keyboard into pairing mode. You can see this little flashing light here, that's in pairing mode. And I'm just going to reset the Pico microcontroller. So same microcontroller, I just hit reset. You can see it's going to attempt a classic. It's scanning, it's not seeing it because I don't have that black keyboard in pairing mode. So now it's going to look for a BLE keyboard. It's scanning. Yeah, no classic devices found. We'll try BLE after timeout. I'm going to come over here so that I can catch it when it connects. Is it not connecting? Let me just reset the Pico again. Oh, and I've got to set. Oh, it is never gonna connect right now because I forgot. I have a variable, and someone might have seen this. Someone might have seen this in the code here. Scan mode. I actually have it right now just in Bluetooth Classic mode. So it was although one of my messages is confusing, it was never going to look for BLE. So I'm going to change this to both. So now it's going to scan first Classic, then BLE. So I've changed this to both. And I'll set the debug mode to true. So we'll see more messages. And I just have to tell Arduino IDE what board I'm trying to write to. So let me... Raspberry Pi Pico 2W. And sorry you're not seeing this stuff here. I'm picking the serial port, and I'm telling the IP v4 stack to be IPv4 and Bluetooth. All right, so let's see. I'm going to put the Pico into bootloader mode and then tell the IDE to compile. I haven't compiled on this machine in a while. Hopefully it has all the right libraries, crossing fingers. Otherwise, I'll try the other, this one, I may have left this in both mode, we'll see. So this is uploading. It's actually compiling and then uploading, so it could take a while for the first compile, sorry about that. And all of this is based on a couple of different Bluetooth stack efforts out there. There's BT stack, and there's this Bluetooth HCI and Bluetooth HID library that I think those two are from Earl Philhauer, who is updating. There was one issue I found where it only wanted to connect to BLE and not classic Bluetooth, but he found the library was fine, but the example sketch was not attempting Bluetooth Classic, and he has updated that. So if you look in Arduino IDE under the, I think it's the Bluetooth HCI example, you should see one called Keyboard Piano and Keyboard Piano BLE. They should both work now, one with a BLE keyboard, one with regular classic Bluetooth. Under the, I think it's the Bluetooth called Keyboard Piano, now one with a BLE keyboard, one with regular classic Bluetooth. Or the N key rollover is better on Bluetooth Classic versus BLE, and I think the ability to reconnect is a little better. So I don't know if Keychron is claiming keyboard, but I think gamer keyboards are maybe more likely to be using Bluetooth Classic versus BLE, but I suspect they're both just fine because I've not noticed any problems using that JPPPoW BLE keyboard. All right, we are 70%-ish compiled. Let's see if it can now find the device. It's found it. It's flashing. It's updating. And it wrote. Okay, it's restarted. You'll see it's now scanning for BT Classic devices. I'm going to make sure that this one is in pairing mode. I think it's going to fail the Classic and now try for BLE. And we're there. Okay, so that connected. I don't think am I still? Yeah. Oh yeah, I am. Okay. This is now the BLE keyboard. So you can see both the text where I'm able to type inside of the IDE serial panel here is collecting the text that I'm typing, but you're also seeing these events, these keyboard events, and these are sort of, I think, the hex codes of the keys as interpreted by the Bluetooth LE stack there. So this will work with, you won't see me pick all with Windows all, but that's what it would do. Oh, it does work there, okay. So keyboard combos work, caps work, I think caps locks works. Yeah, caps lock works. All that stuff works. Function keys, escape, etc. Only one that I didn't see working through this was media control. So this one has a little volume encoder on here, which is nice. I may look and see if I can get consumer control stuff working as well and do an update. But that works very well. If I put this other one into pairing mode, it's in pairing mode. I can hit the reset on the Pico, and you'll see here it is now trying to find it, scanning for Bluetooth Classic devices. Found it, it's connected. We should see a bunch of messages here now that we weren't seeing before, just in the debug mode. So that just happens to be showing the full messages there. I just have it printing it a little differently. John Nudge says, oh, you're asking a lot from that computer. How's the audio? Is that still working? Hope so. Crossing fingers. So there you go. It does actually also connect to mouse. I have confirmed that it works, but it's not was not my goal. So if you want to try using, should work with a BLE mouse. I don't know if there are Bluetooth Classic mice, but it does seem to work with BLE mice. Another interesting thing is that some game controllers, particularly ones meant for kind of casual gaming, this is one of these little miniaturized, also 8BitDo. Can you tell I like them? They will have a keyboard mode. So on the little selector switch, it lets you do, let me hide this window here. There's a little selector here that'll let you connect to a switch on S, connect to, I think, to DirectX with the middle one, the D, so it looks like an Xbox controller, or K, it actually shows up as a Bluetooth keyboard. So this little thing, not BLE, if I hit reset on the Pico here and fire up this little keyboard, or sorry, this little controller that's going to act like a keyboard, so that's in pairing mode now. And you look here, it just found 8BitDo Micro Gamepad. Classic HID connection complete. If I clear this out here, you can see G, J, H, I, E, F, D, C, S. So there's just like 13 or however many buttons are on here. They just come as keyboard keys, which is really useful for mobile gaming, where you may be able to just say, instead of a Bluetooth controller, I want letters, or more like an emulator. If you have an emulator running on mobile or running on a whatever, you can, without some of the complexity of a game expecting real gamepad, just say, you know what, it's as if I'm playing with a keyboard. It just happens to be in the form factor of a little controller, but it's actually a Bluetooth Classic keyboard. That's what it shows up as, which is wild. There's probably more devices like this in my life than I know of, but I thought that was pretty neat to see. That's not BLE, it is Bluetooth Classic. It's showing up as a keyboard. If we switch to this next mode over, I don't think it'll connect here because it's going to look just like a game controller, and I'm not doing that, but I can connect to my computer as a game controller, or I can connect to my computer as a Bluetooth Classic keyboard. So there you go. Gosh, no, Toddbot over in the chat says JP is the Bluetooth HID master. Not at all, but this is confusing stuff, but I am excited to have it working. I did a couple little modifications to a 3D printable case. I can post that if you want, but this is a Ruiz Brothers Pico case. I just made a couple small changes to it. I think this one maybe had the strap wings on it, and I added a button there, or a cutout there for the LED, and this just lets you click the reset button, which is all you need. So there you have it. There is a bunch of, yeah, Tyeth Gundry says it's surprising that this little thing doesn't use WASD for the keyboard D-pad. Yeah, you will have to map things if you try to use this with an emulator that's expecting WASD, WASD for up, down, left, right. But there you have it. So that is the Bluetooth. This is in Learn Guide as Bluetooth Unified Keyboard Bridge if you want to go look at it. It is up. I'm writing a guide for that. Robert Cochran, what is WASD? If you look at your keyboard on the left-hand side where the WASD keys are, that's essentially arrow keys for your left hand. So early games might have used the up, down, left, right arrow keys over on the right. But with mice, it's nice to use your left hand, and there is no arrow keys over there on a normal keyboard. So yeah, forward is W, backwards is A, or S, left is A for strafe, D is right for strafe. So that kind of doom movement, that's common in a lot of video games. So that's what WASD is, W-A-S-D. All right, that covers it. Before I go, I do want to remind you about the bleed teeth. The bleed teeth? The blue teeth. Blue teeth. Blue teeth. That is your coupon code. Head on over to adafruit.com. Look for some neat stuff. Perhaps a Pico 2W. Perhaps a Pico W. Perhaps the Pymaroni thingy. Look at these. These are lovely. Here's what I'm using. Let me go back over here. Pico 2W. Whoa, come here. If you follow that little, hey, it doesn't like that. Pico 2W. 2W. Pico 2. Whew. Oh my gosh. Why won't it? Pico. I can't search anything. Too many search errors. I've broken something. It's suspicious of me. Let's go. Are these under Raspberry Pi? I don't know categories wise. Can we get there? There we go. Closer. Phew. Okay, so you don't need headers on it, so you can save a buck there. This one right here, great choice for it. Raspberry Pi Pico 2W. Maybe you can search for it. Or the Pymaroni version is the Plus. Let me try searching again. Maybe it likes me again. No. It won't let me search. Well, take my word for it, I guess. Let's just go to Pymaroni. Pymaroni. You cannot use our coupon code on their site, by the way. Well, how's their search? Pico 2W. Pico plus 2. That's getting closer. Yeah, so it's like this one, but it's the W. These are neat because they give you a couple extra features. There's a boot cell and a reset button on here, which is great for going in bootloader mode. Half the chips are on the bottom, and there's some STEMMA QT port on the top, and it's USB-C, which is very nice. But they're a lot more expensive. More RAM on there, 16 megs of flash memory, 8 megs of PS RAM. So anyway, that's a deluxe one that we sell, I promise, but I apparently cannot get there right now. Anything? No, I've broken the internet. That aside, go get yourself a 10% off by using Blue Teeth as the coupon code today, and that's good until midnight tonight. Oh, Adafruit search is down for Toddbot 2, he says over in there. Okay, something that wasn't me broke it. That is going to do it for today. Hey, thanks so much for stopping by. I believe Foamy Guy is doing a deep dive tomorrow, so check with him, check with the blog, check with our Discord server, and then we'll be back on Tuesday with another product pick of the week, and possibly Desk of Lady Ada shenanigans and videos and live streams and things over the weekend. Who even knows? Then then Wednesday morning, 3D Hangouts, I believe, is happening. Possibly, I know Noah's on break, I believe, but Pedro may be doing it. And then double check the blog, double check the Discord. Show and tell Wednesday evening. John Nudge says, not so great search. That was the not so great search. And possibly Ask an Engineer later that evening. So those are some of the shows that we have. Thanks everyone for stopping by for Adafruit Industries. This has been John Park with John Park's Workshop. Bye-bye.
Thank you.